Before talking a little bit more about trigonometry, we're going to take a quick detour and talk about some special triangles. Now, these special triangles are important to trigonometry, but the stuff we're going to learn is actually things you could have learned a long time ago. All you need to know are some basic facts about triangles and the Pythagorean theorem. So what are the two special triangles that we're going to look at? First one's going to be the 45, 45, 90 triangle, and the second one is the 30, 60, 90 triangle. Now these numbers, 45, 45, 90, they correspond to the angles of the triangle. So in this case, we have a right angle here, that's our 90, and these two angles are both 45 degrees. And you'll notice that they add up to 180 degrees, as they should, because these are triangles. And so from this, what we're really interested in are the lengths of the sides of this thing. Now, because of the fact that this is an isosceles triangle, because of the symmetry, this is S and that is S, and we are interested in finding that length over there. Well, this is just a quick application of the Pythagorean theorem. S squared plus S squared is equal to C squared. So 2S squared is equal to C squared. C is equal to the square root of 2 times S, but we actually write this as S squared root of 2. We took the plus case because we're talking about a geometric length, so we'll never talk about a negative geometric length like that. And this rearrangement right here, this is one that you're going to want to get used to. We put the S on this side of the square root so that we don't accidentally confuse it for being under the square root. You can see that if this line is a little bit too long, this might look like the square root of 2S as opposed to the square root of 2 times S. That's just a notational thing to help you avoid mistakes. So that sets up the relationship between the sides of these triangles. So if this side is going to be S squared root of 2. We're specifically going to be interested in when the hypotenuse has length 1. And in order for this picture to have hypotenuse length 1, we need the value of S to be 1 over the square root of 2. And if we do that, we can actually just replace those values right here. This will become a 1. And S is 1 over the square root of 2. 1 over the square root of 2. Right, and with a little bit of rearrangement, this can be written as square root of 2 over 2, rationalizing the denominator. And so there you go. So this is the 45, 45, 90 triangle, and the values that we are interested in are when the hypotenuse has length 1, the two legs have length square root of 2 over 2. Now for the 30, 60, 90 triangle, we're going to set up things in a similar sort of way. We're going to have, this is going to be our 60 degree angle, this is our 30 degree angle, and there's our right angle here. So how do we find the lengths of this thing? Well, it turns out that with a little bit of creativity, we can actually put this into a framework that lets us get access to the sides. Because right now, the geometry on its own doesn't tell us anything. However, if we take a copy of this thing and put it over there, this is also a 30 degree angle, which means the whole thing is a 60 degree angle, and this becomes an equilateral triangle. And so this is what gives us access to figuring out the lengths of the various sides. So now if this side is length S, then this side over here, well, it's going to be half of the side, but since it's an equilateral triangle, all the sides have the same length. And so this is going to be S over 2. And then we can use the Pythagorean theorem to get the third side. I'm not going to write it all out, but basically what we get here is that this is going to be square root of 3 over 2 times S. And just as before, we are interested in when the hypotenuse has length 1. So we set S equal to 1. I'm just going to redraw it down here this time. So if this is a 60 degree angle, and that's a 30 degree angle that has length 1, when S is 1, this becomes 1/2, and this becomes the square root of 3 over 2. All of these values, the square root of 2 over 2 for the 45, 45, 90 triangle, and the square root of 3 over 2 and 1/2 for the 30, 60, 90 triangle, these are going to be the important values that we're going to need looking at some trigonometric functions in a moment. So we're now going to put these special right triangles together with the unit circle picture to actually find some coordinates on the unit circle itself. So you can see that I've labeled our triangles here with the lengths, and I also have these physical manipulatives that fit over these pictures pretty well. Anyway, the idea now is that if we're given a particular angle, we should be able to determine the coordinates as long as they are these special angles on the unit circle. So let's do an example. Let's take the angle 210 degrees. which is this one down here. What are the coordinates of that point? Well, we first go and think about the reference angle. What is the reference angle for this one? Well, as before we saw, it's 180 degrees plus 30 degrees more, so this reference angle is going to be 30 degrees. And what that means is we could take our triangle here, take the 30-degree angle, and stick it over the top of that. And this tells us exactly the horizontal distance and the vertical distance we must travel to get to that point. Square root of 3 over 2 this way, and 1/2 down, matching up with our values here. And so from this, we actually know the coordinates of this point. This point has coordinates negative square root of 3 over 2, comma 1/2. Negative, whoops, comma, negative 1/2. Negative because we're going in the negative x direction, and the negative y direction as well, so negative, negative. What this means then is that cosine of 210 degrees, cosine of 210 degrees is the x-coordinate on the unit circle corresponding to the angle 210 degrees. This is negative square root of 3 over 2, and sine of 210 degrees is negative 1/2. And because of these particular angles that we've chosen, we can always use one of these two triangles to get every single one of these angles. So the 30-degree angle, 45-degree angle, 60-degree angle. Over here in the second quadrant, we can use the same triangles, but we're going to think about the reference angles. That's a reference angle of 60, reference angle of 45, and reference angle of 30. And you just trace that all the way around the circle. Every one of those angles is related back to a reference angle that is either 30, 60, or 45 degrees. And so from this, we can get all of these coordinates. Now, I'm not going to write them all out because it's going to take a while for us to do that. I will put a graphic up that has all the angles and all the values listed. But this is one, again, where you can try to brute force memorize all these points. And, you know, if you can memorize them correctly, good for you. But it's much better to be able to think about the picture and understand how these things go together rather than just blindly memorizing information. We're going to do one more sample calculation involving an angle on the unit circle. Calculate sine of 7 pi over 4. So let's just try to construct this from the beginning. We have our unit circle here. We are interested in the angle 7 pi over 4. Now you might remember that pi over 4 is the same as 45 degrees. So pi over 4 is here. We want 7 of those. So 1, 2, 3, 4, 5, 6, 7. So 7 pi over 4 looks like this. And this angle lies in the fourth quadrant. That immediately tells us that the sine value is going to be negative because we are below the x-axis. Our y value is negative here. And now we just have to remember our 45, 45, 90 triangle. This has square root of 2 over 2, square root of 2 over 2, and 1. So this is how it fits into the unit circle, and this is our 45-degree angle. There's our 90-degree angle, 45-degree angle. So we just think about this triangle, and we shove it into this part right here so that the reference angle, we'll call this one the reference angle, just put that, flip it over, rotate it into there. That tells us that both this horizontal length and that vertical length are root 2 over 2. Since we're interested in sine, sine is the y-coordinate. That y-coordinate in this fourth quadrant is negative, so negative square root of 2 over 2. So you can see that we can get this value by thinking about our 45, 45, 90 triangle and just thinking about the quadrants. And again, this is much easier than trying to memorize the entire unit circle diagram. I mean, yes, if you have that, it's quick to just look it up, but it's much more important to be able to use your logic and reasoning skills to determine this value than just looking it up on a table. Because we can relate all the values on the unit circle back to the first quadrant, it's particularly useful to know the first quadrant values for the sine and cosine functions. And so this is a chart that you can basically memorize, and it'll help you to build out everything else. The fortunate thing about this is that there are certain patterns that exist. So when we build out our chart, we have our two functions, the sine function and the cosine function. And then in the next few slots, we're going to put the different angles. So we're going to start with 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Now again, you should recognize these two from the 30, 60, 90 triangle and the 45, 45, 90 triangle. So that sort of tells you all these values here. But you should also know these values in radians. So this one's 0, that one's pi over 6, this is pi over 4, this is pi over 3, and this is pi over 2. Conveniently, they are all pi's in the numerators, and they count down from 6 to 2. So large denominator to smaller denominator, 6, 4, 3, 2. So what's the pattern for these values? Well, the one that you want to remember is that sine of 0 is equal to 0. And then you're just going to count up. 1 over 2, root 2 over 2, root 3 over 2, and 1. By some magic coincidence of mathematics, this 1 is also the square root of 1. And if you look at the 1 over here, square root of 4 over 2, that sort of completes the pattern. So this is root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2. Why it works out this way, I really don't know. It just does. And so that's one of the sort of magical things about this chart. To get the cosine values, it's the same list of values, but swapped into order. So 0, 1 over 2, root 2 over 2, root 3 over 2, 1. And so this is a chart that you will want to be able to write down very quickly to just help you have that information down on paper when you're doing problems. You can always go back and re-derive these things by thinking about the unit circle and the 30, 60, 90, and 45, 45, 90 triangles and put it all together again. And you should be able to do that. But having these values at hand is a lot faster and will serve you in the long run to know these things inside and out.